Welcome, guys, to HU and Beyond here on the HU Enrichment page. As always, for your host this week, hi, my name's Steven. I do a lot of the tech stuff around here alongside my other coordinator, Marilyn. And if you're curious, on Fridays we do a little thing that we host called HU Flow. So, if you're interested in that, check us out on YouTube at HU Enrichment, also on Instagram at HU Enrichment as well. But today, for HU and Beyond, we have a very special guest here, and that is the lovely Victoria Brain. Victoria is a fellow Harrisburg University graduate of the class of 2019. She graduated with a bachelor's in computer science, and she's here today to talk to us about some coding. So, Victoria, welcome.
Hi, everybody. So as Steven said, my name is Victoria. I graduated last year from Harrisburg University with a bachelor's degree in computer science. Today, what we're going to be kind of talking about is to do kind of an early participation in the Computer Science Education Week Hour of Code. Now, this Computer Science Education Week is actually, I believe, the 7th through 12th of December, so we're a little bit early. But we'd still like to make sure that we participate because we've got a lot of good speakers packed up through that week, so we wanted to make sure that we could get it in here at some point. So what you're going to see from me today is I'm going to share my screen here in a second, and you're basically going to get kind of a walkthrough of how to start some programming, and then we'll just kind of spend time. You can watch me program. You can follow along if you'd like. So let me go ahead here and share my screen so you can see. All right, so hopefully what you see here on the screen is a Google Drive. Now, there should be a link to this in the comments if you're watching this live. If you're watching this as a recording, it'll be somewhere in the comments of that video or posted in the notes or things like that. This Google Drive has a lot of the resources that I'm going to be using throughout this next hour, as well as some things that you can use after we're finished. So if, say, you're a teacher and you want to show this to students in class, you have the recording, you have some resources. If you are just a student and you're trying to get a hold of it and you're trying to program with me right now, I know it's going to be a lot of information, so I wanted to make sure you guys had notes. So there are 3 programs here that you're more than welcome to download as you'd like and take a look at them yourself. But we're going to look at this one here, this Turtle cheat sheet. And if you open this up, this has everything we're really going to kind of be talking about today, and it has it all written here. So if I move too fast, you still have a copy of it for you to look at yourself. There's 2 options for programming if you would like to do this today or whenever you plan on looking at this. But if you would like to follow along, you have 2 download options. I'll get to there in a minute. And then the rest of this has the commands we're going to be talking about. It has the command, it has the description of what that command does, it's in that 3rd column, and then any information that that particular piece of code requires in order to make that function work properly goes in that 2nd column. At the bottom, there is a link to the full documentation for the Turtle stuff that we're going to be talking about today, if you want more information. So if you would like to follow along with what we're going to be doing today, you have 2 options here, and there are links right here in this Google Drive. The first link here is this python.org. And what that takes you to is this page here where you can download the full version of Python and install it on your computer. That's going to be great for if you have your own computer, or say your school lets you download your own version of Python or whatever programs you want to have on your computer. It'll be all right there for you to see. If you cannot download things, and if you want to start programming right now so you can follow along with me, this can take a little bit of time. So we're going to go for our option number 2, which is Trinket. Okay, so the web page is just trinket.io, and you can sign up for a free account as long as you have, an email, and you can put in a password, or you can use a Google account. Sign up for your free account, and then you can start programming immediately if you want to follow along today. So I'm going to go ahead and sign in here. You will click on that green button that says create free account. I'm going to sign into mine, and then we will go ahead and get started. So let's take a look at some pre-built codes. So these are ones that I've already created, and I'm just going to kind of use them to show you what we're going to be talking about. So the tool that we're going to be using is called Turtle. And Turtle is a library in Python, which is just a kind of a collection of resources. They all tend to be related to one another. And Turtle is a drawing program. So basically what happens is you write lines of code. Those lines of code execute in a window that shows a drawing of whatever your commands turned out to be. So for a very simple one, I have this spiral program here. So let me go ahead here and I'm going to put this in my main so that I can run it. And when I click run, you'll notice on the right-hand side of the screen, you'll see that this is actually drawing something. Okay, so these lines of code, these just few things that I typed in right here, turned into this really cool looking spiral on the right-hand side here. If you're using the full version of Python, your drawing will pop up in an extra window. But if you're using Trinket, they'll pop up side by side, kind of like this. So that's what we're going to be doing today. We're going to kind of be talking about Turtle, and we're going to talk about a few very basic Python or any programming language in reality commands to kind of help you really get started in programming if it's something that you might be interested in. So let me go ahead and make sure that you can see all of this. So in order to get started with our project here, we need to make sure that we can include all of those Turtle resources inside of our program. So if you're following along, you're going to copy exactly what you see here on the screen, and I'll kind of explain it as I go. What we're going to do is we're going to use the word import, and we're going to say Turtle. Okay, now Turtle is that library. Okay, this library has all of those resources and all of those functions and information that we need in order to actually make this Turtle program run, to be able to draw these cool pictures and do cool stuff. So now that we have collected all of our resources, okay, that's all we need is out of that Turtle library there. Now we've collected all those resources. Now we just need to start building. In order to start building, we need two pieces of information. Okay, these two pieces of information are going to represent the cursor, which creates all of the drawings, and the screen, which is going to be, the window that pops up, or that window that pops up on the right-hand side of our Trinket screen here. So in order to get started, we're going to first create our turtle. So I'm just going to say t equals turtle.turtle. Please make sure you're following along. Make sure you have this spelled and capitalized exactly as you see it right here. The Python and any other programming language, they're very, very picky about making sure that everything is spelled correctly. It's not very good at kind of trying to read your mind and see what's happening. So what we've just created here is a variable. Okay, this variable is called t. We could name this whatever we want. So if you want to give your turtle a fun name like George or, Speedy, if you want to give him a cool, fun name like that, you can more than welcome to do that. And all you would do is change this right here. But for simplicity's sake, and it makes it easier for me to type quickly, I'm just going to call my turtle T. What we did here is we opened up that turtle library and we grabbed the turtle information, so that cursor that's going to move around on our screen. And that's all we did here. And we stored that information in our variable called T. Variables are really good for storing any kind of information that you want to store. In Python, these variables are very relaxed and laid back. They don't require a lot of extra work. You literally give it a name, you put some data inside it, and call it a day. If you're familiar with other languages, you'll know that variables in different programming languages, some of them are a little bit more picky and you need some extra information around them. So now we have our turtle variable, and this will allow us to modify our turtle or our cursor by just modifying this t variable instead of having to retype turtle.turtle all the time. Similarly, we are going to create our screen, okay, so we can make sure that we can control that. So to do this, I'm going to do something very similar. I'm going to create a variable. I'm going to say s equals turtle.screen. Okay, and this screen is going to control this window. This command here is more important if you're using the full version of Python where it pops open in an extra window, but we're still going to use that here in Trinket just so that we have consistency no matter what kind of Python environment you choose to work with. So now I have my turtle and I have my screen. I can modify my turtle to move around and draw and change colors and whatever. I can modify my screen to have it do different things and change colors and things like that. To get started here, we need one more line of code. And again, this is one that's more important if you're using the full version of Python, but for consistency, we're just going to make sure we include it in here as well. And this is this command here, s.exit on click. Now, if you're using the full version of Python, what happens is your drawing immediately closes the second it's done, which means you don't get to see what you just made. And if you have a problem that you need to fix it and change it, you don't get to see what maybe changes you need to make because it closes right away. So what this does is it's modifying our screen. It's saying, okay, for my screen, which refers back to this S up here, I only want you to close it if I click on it. That's what exit on click means. So that means if I double clicked on this over here, this would go away. If you're using the full version of Python where a second window pops open, you click on that screen and then it closes. That way you can just see all of your drawing. Now, any of the other code that we're going to be working on is going to go in between these lines because we need to have access to my turtle and the screen, but we don't want it to close before it's supposed to. So we need to do all of our programming right in this open area right here. Okay, if you're looking at that PDF that's on the Google Drive, you know, there's a note right here that's something like write all of your code here. Okay. This line here, that starts with a hashtag, is called a comment, and it's how we leave notes in our programs. You're never going to remember everything you did in your program, and if you have somebody else that needs to look at your program, maybe it's a teacher, maybe it's a classmate, maybe it's a coworker, you know, you need to make sure that you have notes in there because code, as it gets more complicated, it gets very, very hard to read and very hard to understand. So it's important we leave notes for ourselves and for anybody else who might need to take a look at this. So now that we have our environment all set up here, what I'm going to do is I'm just going to click run, and you're going to notice my spiral is going to go away and it's just going to kind of sit there and look at nothing. Okay, nothing happened. It's all just plain white over here. Nothing changed, and that's okay. Anything we did over here, it's nothing we can see. We didn't draw anything. We didn't make any colors. We didn't do anything different. So it's okay that that doesn't show anything, but because it didn't give us an error, it means that we're on the right track. So let's start with some very basic movement so that we can start making some cool drawings. All of the movement is going to be the turtle's movement, so our T. So anytime we are going to move or change the color of, or make it faster or slower, anytime we're doing something that relates to the cursor, we always need to make sure that we are referring back to this T variable where we stored that cursor. So that cursor has information, and anytime we change it, we can't just say change the cursor and then not tell the computer what cursor we're talking about, because it's going to get very confused. So we're going to do a very simple, we're going to move forward a couple of steps. So I'm going to say T dot forward, and then I need my parentheses here. Now, this is called a function. Okay, this function, because it is some variable dot and then a function name, this is a specific function that refers only to this T. I can't just say forward and expect it to know what's going on because it turned yellow here. It's not defined. It doesn't know what it's trying to do. But if I see T dot forward, it goes, oh, okay, I'm going to go to my T variable and I'm going to do something with it. Now the forward function needs some extra information. Okay. These parentheses, you'll see that there's a lot of them. Any function that we use needs to have parentheses because that's what holds any extra information that our program may need in order to do its job. In this case, we can say forward, but how far forward? What direction forward? What it doesn't know what it's doing. You need to be very, very specific when you're doing your programming. So I'm just going to say move forward by 100. Okay, so that's all we've got. We've got our basic outline here. We've got all the stuff we talked about before. We're just going to add a T dot forward, and we're going to go forward 100 steps. I'm going to go ahead and run my code here, and you'll notice now my cursor popped up, and I drew a nice little straight line. So you may be thinking, well, I said move forward 100. That's pretty small for 100. This is actually measured in pixels on your screen, so it's moving forward 100 pixels. And pixels are super, super tiny, which is why 100 of them actually isn't quite that many. On my screen, it looks like it's about an inch is all it moved when I moved it 100 spaces forward. You can also see now we can see the cursor. That's what this little triangular shape here is. That's just the cursor. We didn't actually draw that. But we moved forward. By default, the cursor is going to be pointed towards the left of just towards the right of your screen. Unless you change that angle, it's always going to scoot right off to the right side of your screen. So let's change that first. I am going to now add another line here. And we're going to kind of see how this changes here. So I'm going to say another command. So I'm going to say t.right 90. Now this is another function. It's called right. And this is going to rotate our cursor clockwise by a given number of degrees. So in this case, what I'm expecting to see is my turtle to move forward and then turn right by 90 degrees. So turn clockwise. So I'm going to go ahead and run this, and you can see now my cursor is rotated so it's pointing down. This is another really key aspect of programming, is that everything will always happen in the order in which you put it. Okay, because I said go forward, then turn right is going to be very different than if I had put these in different orders. If I had said turn right and then go forward, my output looks super different. So we always need to make sure that anytime we're doing any kind of programming, we put our steps in the right order, because the computer's going to execute them one at a time, one after the other, until we get all the way to the end. Okay, so we can combine these as much as we want. We also have two other functions that are very similar to these. We have t.backward. And we can say whatever number we want in here. And t.backward, so normally our cursor moves in the direction of this pointy end. T.backward is going to move the opposite direction. We also have t.left by, whatever degrees that we want to put in here. Let's just do our 90 here. And this, instead of turning clockwise by 90 degrees, we would turn counterclockwise by 90 degrees. Any of these functions can take any number as information extra. So we can move forward however many steps we want. We can rotate by any degrees between 1 and 360. Right? We can put any of those numbers in there. You can even do more than 360 or just kind of spin around and around and around. So there's a lot of stuff that we can do with just these basic movements, right? We can put them together to build shapes. We can put them together to build all kinds of stuff. So as a very basic thing, we could build, let's say, a square. Let's do a square. A square will be a little bit easier for us. So if I go right 90 degrees, then forward 100, what I know about a square is that it has 4 sides that are all exactly the same. And I know that it has 4 angles. All of them are exactly the same, and they're 90 degrees. So what I can actually do here is I can copy these, and I can just make sequences of these. I'm going to turn right, then go forward. I'm going to turn right, then go forward. I'm going to turn right, and then go forward until I have 4 forwards to make my 4 sides of my square. When I run this, you'll notice it's going to execute all of those steps, and we are now have a cute little square on our screen here. So there's the basics of just moving. Now, this obviously looks a little bit bland. It's just kind of black and white and nothing super fun to look at. So we can actually make this better. We can add things to this. We can change colors. We can change the background. We can make our lines thicker or thinner. And also we can make our cursor move faster or slower. When I did the spiral one, you'll notice that the cursor moved super, super, super fast. Okay, and that's because if I'd left it on the normal speed, we'd be sitting here forever just watching it draw a little spiral. So we can change all of those things. So I'm going to leave my square right there, and right above my square, I'm going to include some extra lines of code so that way I can change what my square might look like. We're going to start with pen size. So t.pen size. Okay. This one also is going to take a number as a size, and this is going to change your pen thickness with respect to pixels. So if I said I want it to be a pen size of 10, my pen is going to be 10 pixels wide. So every line I draw is going to be 10 pixels wide. So you can see it got nice chunky lines here. Okay, so you can make this big or small or whatever. I believe it defaults to 1, and obviously you can't really have a pen size of 0. It's not going to really do anything. So we can do as much of that as we want. We can also change the pen color. So T.pen color. Now what this takes is, instead of a number, is it's going to take a color. So we can use colors that are formatted as strings, which is another kind of data that the computer recognizes. Strings are text, any kind of just plain text. It could look like a number, it could look like absolute gibberish, it could look like a sentence, anything like that, as long as it includes quotation marks. These quotation marks, actually, I tell the computer, hey, this is plain text and treat it as such. Okay, that means I can't do addition with it. That means I can't do anything crazy with it. I can't divide a string. You know, I can't do that with text. I can only do that with numbers. So what you can do in here is your string is just going to be your color name. So if I said red, I can now have my square will be drawn in red. You can experiment with what kinds of colors that this program identifies. It can do at least the very basic rainbow. It can do a couple of other ones like you know, black, and, you know, if you did brown or other colors similar to that, that they're not really ones you think of immediately as a rainbow, but, you know, it can definitely do that. So if I want maybe my line to be teal, you can see now it picked teal. Okay, so you can play around with what kinds of colors you want, and what kind of colors that this program will actually recognize when you write out the word. So I'm going to leave my pen just kind of like that. I'm going to leave it nice thick lines, and I'm going to leave it teal because I think that's a pretty color. So what else can we do here? So let's say I needed to draw 2 squares and I don't want them to touch. Okay, I have other things that I can lift up my pen and move it around on my screen so I can go someplace else. And I can also fill in this shape. So there's a lot of other things that we can do. Before we start drawing another shape, why don't we just fill in this shape here? So in order to fill in a shape, we're going to need a couple of things. First, we need to decide what color are we filling this. So we're going to say T.fill color. And just like pen color, we're going to give it a color that we want to fill it with. I'm going to fill it with purple. We're going to it'll be a very, very fashionable looking square for us here. And then we need to enclose anything that we want to fill with a begin fill and an end fill. And that way it kind of says, okay, start filling here, end filling here. So it knows anything that this just drew in between these 2 lines of code, that's what's going to get filled in with my shape here. So I'm going to fill this in purple, and I'm going to say T.begin fill. Does not take any extra information. It understands completely what it's supposed to be doing here, so I don't need to give it anything extra. I'm just going to say begin fill, and right after my square I'm going to say T.end fill, just like that. So what we should expect to see is, obviously, our square is going to still be here, our pen color is purple, and what we should see then is that our square here should be teal on the outside and purple on the inside. So let's go ahead and run this and see what we come up with. There we go. So we've got our teal square and then purple on the inside. So now we can start really filling in kinds of shapes and making sure that we get what we want when we're trying to make a drawing here. Let's go ahead and do a couple more commands. Let's make another shape here. Let's make another square. But in order to do this, I want my squares, I don't want them to touch. I want 2 perfect squares on my screen with nothing connecting them or anything in the middle. So what I can do here is I'm going to introduce you to 3 new lines of code here. First one is we're going to say T.pen up. Okay, this pen up does not take any extra information in those parentheses. You just leave them empty because it knows what it's doing. And what this is think as if you're writing or drawing and you want to move to the next word, to the next shape. You lift up your hand, or at least you remove the pen or pencil from the paper, and you move to the next space where you're going to start writing. So this function does the exact same thing. It's going to pick up that cursor. Think of it as it picks up that cursor off the screen, so we can go anywhere on the screen that we want in order to and then so we can start drawing something new. So we've got our pen up. Now, the next function I'm going to introduce you to is goTo, t.goTo. Now, the goTo function is very, very useful because it helps you to, like, really, if you really want to plan out a drawing and you want it to be very, say you want it symmetrical or you want certain things to appear in certain places, very, very specific places on the screen, goTo allows you to move your cursor to a specific point on your screen. And we have to think of our turtle screen here as a coordinate grid. So where our turtle cursor starts, so this spot right here, is actually considered 0, 0. So if I want to go up, I need to make sure my y value is positive. If I want to go down, my y value needs to get negative. If I want to go towards the right side of my screen, my x needs to be positive. If I want to go to the left side of my screen, my x needs to be negative. So we're going to use a coordinate point and think about our screen over here. So if I want to move my cursor, say, up in this area here to draw another square, I'm going to make sure that both of my x and y values are positive. So I'm going to go to 50, 50. So 50, my x is going to be 50, my y is going to be 50. So I'm going to end up over here someplace. And once I get there, I'm going to say t.pen down. And that's going to allow me to put my pen back down so that I can start drawing again. Okay, so let's go ahead and run this just so we can make sure we've got everything correct and you can kind of see what we've been working with here. So we're going to draw our square again, fill it in, and then we moved. So notice that when we moved from here to here, we didn't actually draw any lines. We just picked it up and moved it. And now I can draw another shape, any other shape that I wanted, anything else. The next shape, just because it's very hard to get curves when we're using just forward or backward or left and right. It's very hard to get curves. So we actually have a built-in function called circle. So I'm going to say t.circle, and this can take up to 3 pieces of information, but we're only going to really focus on 2. If we just give it 1 piece of information, what this is the size of the circle, measured by the radius of the circle. Okay, so the radius is half of the width of the circle. So from the center to the outside, how many spaces are between there? So if I want my circle to be the same size as my square, I need to make sure my value I put in here is 50, because 50 is the radius, means the diameter is 100, so it'll be a width of 100, just like the width of my square here. So let's go ahead and run this. So we do that, and there we go. Now we've got our circle. Now, we do 1 piece of information is going to give us the size of our circle. If we want to draw just arcs, or say you want to draw a flower and you just kind of need to turn a little bit, or you want to draw leaves, or whatever you might want to draw, you don't have to draw the full circle. Okay, so this is again where you're going to have to be thinking in terms of, math and geometry classes, thinking about your angles. So an entire complete circle is 360 degrees, which means I can draw part of my circle by just saying how many of those degrees do I want to draw. If I draw 180, I'm going to get a perfect half circle. 90 degrees is going to give me a quarter of a circle, and I can draw any number between 1 and 359, to give me up to a whole circle here. So if I say I want to draw 200 degrees of my circle, when I run this, now you'll see why sometimes changing the speed can be important. I only drew 200 degrees of my circle. So I only drew a little over half, because half is 180, so I drew a little bit over half. And now that we have all of these, you can combine these in any way that you want in order to really make some really, really cool projects. Okay, so this is very straightforward, where you just kind of practicing with shapes, and you're practicing with circles, and you're practicing with colors and fun things like that. But you need these basics in order to actually build very, very cool things. Last thing I want to show you, 2 more things, just so speed, because obviously we have to watch this the whole time every time I rerun my code. So I'm going to make sure that we know how to change our speed here. Right up here where I'm going to change my pen, I'm going to say t.speed. That's speed. And the speed varies from 1 to 10. So where 1 is slow and 10 is fast. So I'm going to make it go fairly fast. I'm going to say 8, so that way it moves a little bit faster. And the last one I want to show you then is background color. So remember this S variable we created here, this controls our screen. And if we want to change the color of our screen, we're now going to make sure that this function is S dot instead of T dot because we're changing the screen's color. So I'm going to go down here and I'm going to say S dot BG color. And just like every other color with pen color, fill color, whatever, choose a color that you want this to be. I'm going to set my background here to yellow. And off we go. Okay, so now that we've got all of that, let's run it one more time, see what we've got happening here. You can see we're drawing a lot faster, and it goes in order. So we changed, the last thing we did was set our background to yellow, so that's the last thing that we saw pop up there on the screen. All of these commands are included in the Google Drive that is either posted in the comments or in the informational section of this video. So make sure that you check those out because I'm going to have to delete these here in a second. And if you're following along, I want to make sure that you know that these commands are still someplace. So you don't have to worry about rushing to make sure that they're all written down. I know an hour is kind of a quick time to learn the crash course of programming, but we're going to make it through. That's why we've got notes. So I want to show you a couple of these other projects that I have up here. So I have the spiral we already saw. I have a jack-o'-lantern. I have the HU and Beyond logo, and I have another one that's like a turtle race. Okay, so I'm going to go ahead and I'm going to delete everything I just did. Very sad, I know. And I'm going to go ahead and we'll start with the jack-o'-lantern, right? It's only the very beginning of November, so Halloween wasn't that far away. So I'm going to go ahead and copy all of this. And we're going to put it in my main function here. When you work with Trinket, you're allowed to have extra files here, but only the main is going to be running. So anything you do needs to be copied and pasted into the main.py tab here. If you're using the full version of Python, you can have as many files as you want and run them whenever you feel like it. So you can see this is actually a very long code here. I've got 94 lines of code from beginning to end. And but we're still using the very basics here. So let's kind of go through this bit by bit here. So we've got our basics. We're starting our turtle. We're creating our cursor. We're creating our background. We're setting our speed to something a little bit faster, so we're not going to be sitting here and staring at this for a while. We've also got, we changed our background, so it's going to be orange, which is, lovely for our pumpkin here. So I see we have a question here quick of how do you troubleshoot if a command doesn't work? Well, it depends on what you're using. In Trinket, which is what we have here, Trinket, Trinket will kind of highlight things weird. So let's go ahead and say I forgot to type in my T right there. So it just goes .speed. Well, when I go and run this, you'll notice that this popped up red and it highlighted my line. If you're using the full version of Python, sometimes it can be a little bit harder to pick out. Python will highlight things like this. Sometimes all it will do is pop up an extra window and say, hey, there's something wrong, and it'll give you a line number, and you're going to have to kind of figure it out for yourself. So this Trinket is a very good place to start because it's very good about making sure that, it gives you all the information that you need. And then if you can't figure out, because right here it says it just gave me bad input, and I knew what I did. I knew what I did wrong because I was the one that broke it. If you don't know what you did, refer back to any notes that you might have. Make sure things are spelled and capitalized correctly. If you need to Google something, so sometimes the errors Python can give you are kind of vague. And if you're still a new programmer, you don't have somebody you can ask for help, like a coworker or a classmate or even your teacher or something like that. Sometimes just Google can be a good thing where you just say, if it gives you a very odd error, you just can put that into Google and hopefully it'll kind of point you in the right direction of what might be the problem. Errors are very, very common in programming, especially when you're beginning. Obviously, if you're just kind of following along with me, you can copy what's on the screen here. But if you're doing this on your own, things go wrong, and it's very, very common for things to go wrong. So be patient with yourself, be patient with your computer, and just try your best to make sure things spelled correctly, capitalized correctly, and all of that other good stuff. So we're working on our jack-o'-lantern here. We've got our speed, background color. We're good there. Now, this is something new. This is something we haven't talked about yet, and this is called a function. So we've already seen functions, right? We said t.speed, s.bg color. all that stuff, t dot forward, those are all functions. But what this block of code is here is actually a function that I made myself. The functions we've been using are all built-in functions, which means somebody else did all the hard work and we can just take advantage of that. If there's a time when you want to make something that, something new that nobody else has maybe created before, functions are really good because they work almost like a stamp. Once the stamp is created, you can use them as many times as you want. I can use the t.forward command, and I just have to say t.forward. I don't have to figure out how to make sure that the pixels on my screen change color and only this many and in this direction and all of that. Every time I want to go forward, I don't have to think about all of that. Somebody else made that for me. So I have two functions I created here so that I can do less thinking later. And I have triangle and square. Okay, so triangle, as it kind of sounds, is going to create a triangle for me. And a square is going to create a square for me. So that way I don't have to keep retyping all of this stuff. It can just kind of pop up for me. This functions have a couple of key important pieces. First is this keyword def. Okay, this that turned purple here, this is something that's really important. And a lot of the Python and other language editors, what they do for you is they change colors to let you know, hey, I know what that is. I know what I'm looking at here. So Python's like, hey, I got you. I know what this is. And it kind of can give you a little bit of peace of mind so that you know that Python's kind of working here. The next piece is this name. Okay, my function name is triangle. And then anything that goes inside these parentheses is a placeholder for that data that gets sent. So if we look at this bg color function, someplace when somebody created this function, they have placeholders. So when I send them information, they can store it someplace until they need it later. So that's what we got here. So this triangle function takes a side length. So that's going to give me how big my triangle is and what color do I want to fill in my triangle with. And then it's going to do all that for me and draw my triangle. Same thing with square. Okay. Any commands that you put inside of a function need indented in Python. In other languages, you may use curly brackets or other things like that to kind of highlight that. Python just cares about this indentation here. Anything that marks that indentation says, hey, this is underneath and inside this function. So make sure that that's the only time that it runs. It only runs if somebody calls that function. Now we've got a couple more things. We changed our pen size. We're using our go to function here. So this can allow me to go to a very specific place on my screen. And the reason I use this a lot is because I drew this picture out on paper. And if I did it on graph paper, so that way when I was ready to put it in my program, I knew what coordinates I needed to go to. This is something that's really, really good if you're a new programmer and getting used to how do I take my thoughts that I'm thinking about and how do I really get my computer to really understand what I'm doing, because that can be kind of overwhelming sometimes. Like think about it as if you're learning any new language and you know what you want to say, but how do you make sure that the person you're talking to understands what you're trying to say? And it's the same kind of concept when you're learning to program. It is a language in itself. So unlike a spoken language, programming languages, a lot of times, drawing a picture of what do you want to make, making notes, acting through it, anything like that, because it is a sequence of steps. So anything like that can really help you get your thoughts in order is a great place to start. So in this case, I drew my picture out on graph paper. That way, when I was ready to translate this into my program, I could just use my go-to function and I already had my coordinates that I needed. So I went to my new location and you can see I called my triangle function, and I'm going to draw a triangle with the side length of 50 and it's going to be filled in black. Okay, you'll notice this function, this is one that I made in this program, right? It's up here, def triangle. This does not say t dot or s dot or whatever. And that's because it's a function that can be used for anything inside this file. These ones here that say t dot or s dot, they're ones specific to Turtle. So we need to make sure that we pull them out of Turtle, and that's why we have that t dot or s dot. It's helping to make sure we pull them out of Turtle and modify a specific object like the screen or the cursor. And you can see I have a lot of just kind of moving around, filling in shapes. We have triangle, triangle. So we have 3 triangles. So we have 2 eyes and a nose. And then we see we're using circles here, which is going to make us like a curved looking mouth. And I have some squares, and that's going to kind of give us some orange teeth inside of our mouth. And then here's a function I didn't explain really either. It's hide turtle, and what that's going to mean is my cursor is going to disappear at the end. And that just gives me a nice clean picture. You don't see the cursor popping around or, disrupting what cool thing you just made. So I'm going to go ahead and run this, and we can take a look at this together. So you can see here, we have our cute little jack-o'-lantern face, right? Our background turned orange for us. We've got our 2 eyes, our nose, and our lovely little jack-o'-lantern mouth, and he's very, very cute. And so all of these lines of code created this. Okay, so this is still a fairly simple drawing. It did take a while because making sure you know what locations you need to go to and how big do you want the eyes compared to the nose and how big do you want the mouth, and getting the arcs of using the circle function can be tricky to kind of get that position quite right. So it does take a little while, and it takes some getting used to, but it's definitely a cool place to start when you're learning to program, is to use this turtle, because a lot of times when you're programming, you get kind of bored with it because, well, it's just spitting out some numbers or maybe some words. It's not really anything very fun or cool to look at. So this kind of helps you get into the mindset of a programmer and making sure you understand how to maybe organize your thoughts, how to take your thoughts and turn them into code, and get kind of familiar with how code is written without having to just stare at some numbers and text all day. You can kind of see a very cool and colorful output. We have another couple here. So we have our HU and Beyond logo. This was actually created in the full version of Python. And so it's a little bit hard to see because this window is a little bit smaller. So I'm actually going to pull up another window here so that way you can see. Okay. So this is what the full version of Python, if you downloaded it onto your computer, this is what that looks like. Okay, it's an extra window. It doesn't have a whole lot of other stuff that you can see. It's just very, again, a little bit more bland. It doesn't have all of the numbers and stuff. This one is also a very, very long code. This one has 199 lines of code. So it took quite a while to make sure that I got this right. But you can see we're still using just the basic functions that we've been talking about, right? We have pen up, go to, pen down. And here's another function that I made. It's called turn and go. And I made this, even though you can see up here, it's a pretty small function. It's very tiny. But if I had to constantly type 3 lines of code every time I wanted to turn left and then go straight this many lines, it made my code even longer. So I made a function, and I could just say turn and go, and I could say, okay, what direction do I want to turn, right or left? How many degrees do I want to turn? And how far do I want to move forward? Okay, so you can see if we look up at our function here, we can see another programming concept that we haven't talked about yet. So we've already talked about functions. This is another programming concept we haven't talked about yet, and it is if statements. If statements are very, very cool, and they can turn your program into something very dynamic, something that almost has a mind of its own, or it can make it so that you can communicate with a user, or it can communicate with all kinds of stuff, right? It allows it to do more, and it allows every time you run it, it might be different. So if statements, what they do is they have a couple of parts. So they have the keyword if. Again, you'll see here, this changed colors. So this is Python saying, hey, I got you. I know what this is. We then have some kind of statement. In this case, this statement is if turn is equal to left. So if it's saying if I'm turning left, if I told my function that I'm going to go turn left, you'll notice my execution here is t.left and how many degrees I wanted to turn left. This here is called a condition. Conditions are statements that are true or false, right? Turn equals left. That's going to be true or that's going to be false, and there's nothing else. There's no other kind of middle ground there. It's going to be true or it's going to be false. If has a couple of other parts here. We also have elif, and that just kind of works the same way as if, but using this el kind of signifies that these two pieces go together. They're related in some way. There's one more piece. and that as an else, and it's not actually in this code here, but else, what that does is if true is false, do something else. Okay, so say turn equals left. Okay, if I'm turning right and I have turn equals R, it's going to get caught here. But instead of, if I didn't have, if I just had left, if I said else, well, if left turn equals left is false, it's going to get caught by else. Okay, so if and else are kind of opposites of one another. So we're going to, if it's left, turn left. If it's right, turn right. And how many degrees. And then we're going to move t dot forward by some distance. Okay, so that's that distance value that's right here. And you can see I had a lot of things. I have the H, the U, a plus sign. I wasn't going to do the ampersand. That was going to give me too much of a headache trying to figure that out. So I just did a plus sign. And then beyond, all spelled out. Okay, and here's where we'll really see how this exit on click function works. In Trinket, it's not super important because our drawing is going to stay there. But in Python here, in the full version of Python, our drawing would close if I had just gotten rid of it, if it wasn't there. So I'm going to go ahead and run this. And if you're running in the full version, you're going to go to Run and Run Module. And you'll see an extra window pop up here in a second. Okay. And there it spells out our HU and Beyond logo. Okay. Now, so this cut off in Trinket, so that's why I wanted to show you it the full way. If I did not have my exit on click, this window would have immediately closed. But now I can keep it open and look at it as long as I want until I either close it using this or I can just click on the screen and it closes. So again, this is how we can take those tools that we just used, the very, very basic tools, and put them together and get a very, very cool result. Okay. Last program that I wanted to show you here is this race. And I thought this was a very cool project. It takes advantage of those if statements again. So let me go ahead and put this here. It's a shorter one. This one's only 44 lines of code. And what happens here is the idea behind this is it's going to have two turtles. You can see here we've got T1 and T2. So we have two turtles on our screen here. And what happens is they kind of race to the end of the screen. Okay, and then whichever one hits the end first, we're going to get a message saying, hey, this turtle is the one that won. So this is another way that we can kind of further add things to our code is we can have many turtles. We don't have to have just one. We can have multiple turtles. So let's walk through this code to kind of see what it's going to do. We're going to pen up, we're going to go to some space, and we're going to turn right and pen down and move forward. So we're drawing a line at a specific location on our screen. We're going to turn our turtle again. We're going to set a score variable. So this is a variable that's not related to turtle. Okay, T1 score equals 0. This is going to allow me to keep track of score, or it's actually kind of how far along the screen that the turtle has moved. So that way I can kind of measure which one crosses the finish line first. So I'm going to set my score to 0. I'm going to fill my turtle with red, and I'm going to go to this location here. Okay, and then I'm going to do the exact same thing with a different one, except for my location is going to be different. And I'm going to have a blue turtle. So I'm going to have a red turtle and a blue turtle, and they're going to race. What I have next here, while true, we haven't really seen loops. Okay, we saw loops for a second there in the spiral. We didn't really talk about it, but a loop is another programming concept. A loop, what that does is it allows you to have a piece of your code that repeats until something happens. In this case, we're just saying while true. So that means this is going to run forever. It's not actually going to run forever because I can use my sneaky emergency break here. And this is actually cool. It highlights, it says use break to stop the loop cycle. So this is going to make my loop exit. Okay, so while true, do some stuff. There's another type of loop called a for loop. And that one is it works basically very similar, where it's going to repeat an action, but that one you can give it a number of times. So I want to run, 12 times, and it'll stop after exactly 12 times. This kind of loop is going to run until something happens. Okay, it's going to be some kind of condition, kind of like our if statements. Once something happens that makes it true or false, our loop is going to start or stop. Now, we are going to say T1 move equals, and then we have another new thing here, random.randint. Random is another library, just like Turtle, and what random allows us to do is create pseudo-random numbers. So they're numbers that they're not truly random, but they look random enough to be able to kind of add some variety to our program here. What we do basically is choose how far each turtle gets to move randomly. They can move no spaces, or they can move all the way up to 10 spaces. And our program is going to pick a number between 0 and 10 to have our turtle move. And we're going to have turtle 1 move a specific distance and turtle 2 move a specific distance. And that's how we're going to kind of get them to race. We're going to move our turtle forward. We're going to add to our score. That's what we're doing here. We're making our score bigger. So if I told my turtle I wanted him to move 5 spaces, my turtle score is going to go up by 5. And that's just, again, how I'm going to measure to see when somebody crosses the finish line. Lastly, we have another if statement here. Okay, if T1 score is greater than or equal to 275, okay, that means that they crossed that finish line. The red turtle wins, and then this break is going to make our loop stop so that the game is over. If the blue turtle score is greater than or equal to 275, we're going to get this message: the blue turtle wins. And again, we have our exit on click. So let's go ahead and run this and see what we come up with. So now you can see a couple of different things that we popped up. So we got our line drawn, that was our finish line. We had 2 turtles pop up on the screen, and they scooted across the screen at different speeds, and we ended up having it so that the red turtle won. And because we asked it to display some text with that print function here, right? This is what we used, print. What we got is a nice message that says the red turtle wins. If we run this again, there's no guarantee that that red turtle is going to win. Okay, because we used random, it may happen, well, now it happened, of course, that the red turtle won, but blue was much closer to winning, and we can continue to run this, and it's randomized, so they're not guaranteed which one's going to win. So the blue turtle won. And it just kind of makes a cool kind of game, and you could add more turtles to this. You could, do whatever you wanted to these. You can make a very fancy finish line instead of just a straight line. But there's a lot of cool things that you can do with this just based on those turtle commands that we've been talking about. Just those very, very basic commands. Now, obviously, this one here has a lot more stuff that we didn't actually talk about that goes more in depth into learning Python and learning about how to use random, how to use our print function, how to, do, math and add things to variables and stuff, and use loops and stuff like that, which we don't really have time to go into because we're almost out of time for the day here. But it kind of gives us some very cool stuff to do. And you can definitely take anything that you've learned and really go hard and make whatever you want. Okay, once you have these basic tools down and just learning how to move, learning how to structure your program, you can make whatever you want. So I really hope that you guys have learned something today, and I hope that you enjoyed learning to program just a little bit. Again, in the comments or the video description, you should be able to have a link to this Google Drive where you can find resources to these videos. There will be, you'll have this, which has all of the commands that we talked about today, plus might even have a couple extra ones that we didn't have time to cover. And I also have our HU Beyond logo program, the jack-o'-lantern, and a couple of other sample projects that we didn't have really time to cover today, but just some other very cool things that you can do with Turtle. For more information about Turtle, like I said, in the bottom of the cheat sheet here, there is another link. Okay, this link goes to the full Turtle documentation, so you can find all kinds of other functions that we didn't even have time to even come close to today. And then to find more out about Python, there's a lot of really great resources online, or you're more than welcome to send me an email. I'll make sure that the HU Enrichment team has my email, so that way if you had any questions for me specifically, or you just wanted to know how to get started with more involved programming, you're more than welcome to reach out and ask any questions. So I think that is my time for the day. I really hope you guys learned a lot, and I thank you so much for tuning in to HU and Beyond.
Awesome, awesome, awesome. Well, thank you, Victoria, for educating us on the hour of code. We really appreciate that, truly. Um, among other things, this was a really good opportunity for a lot of people to learn about coding. And also, for anyone who's curious, because I just want to ask you one quick question, Victoria, before we go. What got you into coding?
So I don't know. I know that sounds very weird and very random, but I don't really know. I took a programming class in high school,
Hmm.
and um, so I took that programming class in high school, which I didn't really enjoy. I didn't have a lot of support. I did cyber school, so in the time of virtual learning, that's what I did for high school was cyber school. So I didn't have a lot of close support with a teacher. So I kind of had to do a lot of the learning on my own, which kind of stinked. But I made it through the class and then somehow ended up interested in programming from a class that I really didn't like. Ended up interested in programming, interested in Harrisburg University, and so I ended up coming here for a computer science degree. And honestly, I have no more specifics to that at all. That's all I
Hey,
can tell you.
I mean, hey, we appreciate hearing that. Once again, we want to thank you for coming on H and Beyond. We truly appreciate that. And for everyone who watched our little hour of code with Victoria, thank you for watching. We appreciate it. As always, here on H and Beyond, we do this every Wednesday at 3 o'clock. So we hope to see you guys again here next week for our next guest. Um, for anyone's curious about anything else we do, be sure to follow us on Facebook, Instagram, and YouTube at H Enrichment. As always, I'm your host Steven. That was Victoria, and we'll see you guys next time.